Hi, hello, I'm Kamil, and I'm representing Container Labs. And today I would like to show you how to get from zero to a highly available production-grade DCOS. Starting, who am I? I'm currently working as a DevOps consultant / architect, and my main area of expertise is DCOS, Kubernetes, Terraform, automation, Python. So I'm kind of developer / operations. And you can name me as a DevOps, whatever. So today I will tell you a story about a guy named John. And John is an employee of a medium-sized company. His company application provides a web platform for online shopping that handles the 10,000 of clients per day. And John's main area of expertise is around virtualization, Python, Ansible. So overall, he's experienced in automation and some development stuff. And recently, John heard about containers, how they simplify your life, how they allow to scale your application better, how containers improve your deployment phase in your company, and how containers are much smaller than virtual machines. So John thought to himself that this approach can improve his company application very much. So he went to his boss and told him about this idea about moving to microservices, moving to the cloud. And John's boss heard about this cloud hype, and he was very kind of this approach, and made John as a team tech lead for this project. So John was responsible for the whole migration process. So the first thing that John had to do was to find out the right platform for his needs. And he needed a platform that was reliable, highly available. As the company wants to move to the microservice architecture, the platform has to be ready for that approach. The company chose AWS as a cloud provider, so the platform has to support AWS. And as John wants to automate the whole installation, maintenance, and the upgrade process, this platform has to be easy to automate. And also the company wants to introduce the big data analytics in the future to increase the revenue. So this platform has to support the big data also. So after a week of the very long research, John decided that DCOS will be the winner. So DCOS contains several pieces. The core component is Apache Mesos, which is an abstraction layer for compute resources. And it's proven to be scalable to 10,000 of nodes. And it's very reliable and battle tested. And the main users of Mesos currently is Twitter, Airbnb, Apple, Verizon, and of course the Polish major user of Mesos is Allegro. Another component that is responsible for the containers orchestration is Marathon. It's highly available as it contains the active passive cluster with leader election. It supports multiple container runtimes, for example Docker or Mesos Containerizer, which is a native container runtime for Mesos. It supports application health checks. For example, you can attach the health check for your application using HTTP comments or TCP port check. It also supports constraints, so you can say that your application can only run on a host that has more than 8 cores, or you can run only unique instances for each host. Another thing that Marathon supports is a service discovery. So each time you run your application will receive a unique DNS name that you can add the dependencies between applications later on. It also supports load balancing by default. So you're able to provide load balancing for your applications when you scale them. And it also supports the complete REST API. So everything that you will do from the UI, you're also able to do that from API standpoint. And DCOS itself It's a kind of glue between Mesos, Marathon, and much more components, around 30 right now. And it supports virtual IP routing, which is an overlay networking separation layer. So, for example, you can network separate your dev and staging environment. It also supports stateful storage. So, for example, in AWS, you can pin EBS volume to the container. It has some kind of an app store. It's called Universe, that contains several thousands of applications that you can install by default with several clicks. For example, you can install Spark, you can install Kafka, Cassandra, Jenkins. It's very easy, just like an app store on iPhone. You just click several times and you get the Spark cluster running. It supports multi-tenancy, but only in enterprise versions. There is a hack to do that in open source version, but it's not supported. It provides a very pretty UI, very intuitive UI, even for people that are not mainly focused on operations. If they are developers, the UI provides the easy way to manage all the containers that are running. And most important thing, it's super easy to install, use, and maintain. So let's get back to John. After John chose the DCOS as the platform, he also wanted to automate all the installation, maintenance, etc. And he has expertise with Ansible, so he thought that he might use Ansible to do that. But Ansible is a configuration management software, and it doesn't contain any rapid rollback mechanism. And it has hiccups with multiple users running the same playbook at the same time. You are not sure what will be the outcome of that operation. And as the name suggests, it's the configuration management software, not the tool to build the infrastructure. So John had a huge problem. He didn't know what tool he can use to do that. And he went out for a beer with his friend, told him about his problem, and his friend suggested that he should check out the Terraform, which is another cool tool that is very popular right now. And Terraform is a write, plan, and create infrastructure as a code. It allows you to create a reproducible infrastructure. So every time you will run the Terraform scripts, you will always get the same outcome. So the infrastructure, as the result, will be always the same. You're also able to map resource dependencies. What's even better, Terraform builds the dependency graph at the start, so you don't have to explicitly say that the dependencies between component A and B is present. Terraform is able to determine that itself, but you of course can specify that if there is some not so strong dependency, you can say that component A and B are dependent on itself. It has separation of plan and apply phase, so every time you do some modifications in scripts, you're able to see what changes will be done in the infrastructure without applying the changes in real time. So you have much more visibility to what will be destroyed, what will be changed in the infrastructure before you will apply the modifications. It supports multiple cloud providers like AWS, Azure, Google, DigitalOcean, and of course private ones like VMware, OpenStack. And the workflow is all the same between all the providers. So it's very easy to use that, even if you have to switch from Azure to AWS. And of course, if some task is repeatable, for sure it can be automated. And if it can be automated, it can be codified. So John spent the whole night playing with Terraform, creating some basic scripts, and he very much liked how Terraform works, and he decided that Terraform will be the tool of choice for his infrastructure. But there was still one problem. As he chose the DCOS for the orchestration platform and Terraform as the infrastructure as a code, he didn't really have an idea how to connect them, how to marry those components, how to use Terraform to install the COS on AWS. So what people do if they don't have idea about such things? They Google. So he Googled that there's a GitHub project that installs the DCOS with using Terraform. He quickly cloned the repository, modified several variables, and applied the Terraform scripts. And after 15 minutes, when John came back with his morning coffee, he saw that there is a login screen of the DCOS. And he thought to himself, that was very easy. I just had to change some variables, run the Terraform apply, and that's it. DCOS is up and running. So, but he didn't have an idea what really happened behind the scenes. So he started to analyze what happened in AWS, what was created with these scripts. So Terraform created separate VPCs, separate subnets, root tables, etc. for each of the components. So he was very happy. It was very much like he imagined that the infrastructure should look like. But he noticed that there is one problem, that all the management layer of Mesos, which is based on Mesos master instances, were created in single availability zone. What will happen if this availability zone will fail? He will lose all of his management layer, so he won't be able to modify the containers or restart them or start new ones. So, of course, the apps that were running previously will still run as they are executed on separate instances that are spread across all availability zones, but he won't be able to manage them. So John thought to himself that he should modify the scripts to deploy the Mesos masters across all availability zones. And he saw that Terraform uses HCL, which is hash configuration language, and it's very similar to JSON. And John already knew the JSON, so it was very easy for him to modify the scripts. And finally, all the Mesos masters were deployed in 3 availability zones. So as an example of the architecture, how it could look like in AWS, you can have multiple Mesos masters, for example 3, in each of availability zones. Also, you can have a multiple private and public slaves, and all of these instances can be in auto-scaling group to allow the easy of scaling if you need more resources. As for internet access, there's a NAT gateway in each availability zone, so it provides internet access for Mesos masters and Mesos private slaves. As for the load balancers, there are 2. One is for Mesos master internal communication, and second one is for applications that are available from the internet. And of course, all the configuration of Mesos cluster is kept in S3 as a S3 bucket, so it's highly available too. So after a few days, John was still playing with infrastructure, changing some things in the scripts, and very unexpected thing happened. His laptop just died. He saw that his MacBook Pro just had kernel panic, lost all of his data on laptop. Fortunately, he had a time capsule, so he could revert back from time machine. But as all things always go in pairs, the time capsule died also, so he couldn't revert back to the old backups. So basically, he lost all of his data on his laptop. Fortunately, he kept all the Terraform scripts in Git repository, except for one file, which is Terraform state file, that contains the whole infrastructure layout. So Terraform is using this file is able to determine what the infrastructure looks like, what should be changed in case you modify the scripts, what should be deleted, etc. And there is no easy way to import the resources back if you lose this file. So John spent the whole day and whole night importing the resources one by one by hand to get back to the previous state of infrastructure. So very important thing to keep in mind is that the Terraform state file should be configured to stay in a remote location. And Terraform supports multiple backends, such as S3, GCS, etcd, console, etc., and more. One important feature that could be enabled is Terraform state locking. It allows multiple users to work on a same infrastructure at the same time. So if user A applies some changes in the infrastructure, user B has to wait until the previous apply phase has finished. So multiple users using state locking are able to work on the same infrastructure at the same time. And it only supports S3 console and Terraform Enterprise, sadly. Okay, enough of the infrastructure. Let's move on to the fun thing, deploying apps. So as I mentioned, the company has a web platform that handles thousands of clients per day. So John asked the developers to provide the Docker images of the company applications in form of modules and Docker images. So after several days, the developers came back and with the Docker images. So John quickly started to deploy them on DCOS. Firstly, he started to use the UI. So he clicked one by one each of the containers. It was very boring, very painful, as most of the definition of the containers were the same, but only variables changed. So he thought to himself that he will use the CLI or API. And it was not very easy either, as he couldn't template the variables to outside of the JSON definition. So he thought to himself that if there is an easy way to manage all the things with Terraform, how to do that? And he had a great idea. He could write his own Terraform provider to talk with Marathon API to deploy the containers using Terraform. So he started to Google, he started to ask questions on Stack Overflow, got flamed a lot on Stack Overflow. He started to learn Golang, and after several days, he wrote his Terraform provider to talk with Marathon. And running containers on Marathon using Terraform was very easy, as he could just provide one big template of general definition of the container and apply the variables that are unique for each of the company application module. And of course, all the container state was kept in S3, so it was also highly available. So to sum up, Terraform is highly extendable, and it's written in Golang. And if you don't know Golang, or you are not very kind of learner in Golang, there are a lot of community-driven providers and modules that you can use. And don't be afraid, there's a Marathon provider also, so you don't have to write your own. Okay, let's move on to upgrading. How to upgrade DCOS, how easy it is. So, after several months, DCOS 1.9 has arrived. John saw the release log. He saw that there are a lot of cool new features that he could use, a lot of bug fixes that he was waiting for. So he was very excited. He immediately started to look at the changelog and look for the upgrade procedure. He started to Google DCOS upgrade 1.8 to 1.9 for AWS, and there was no results. Only thing he found was an upgrade guide from 1.7 to 1.8, which basically said destroy everything and deploy the new ones. So replace the old stuff with new toys. So, and it was not so very easy, as the Mesosphere, the company behind DCOS, provides the CloudFormation templates for AWS, and John scripts uses CloudInit to install the DCOS. So John spent the whole night looking for changes between 1.8, 1.9 in the CloudFormation templates, migrating that to CloudInit in Terraform, testing, and he left the office at 2 a.m. and decided that he will perform the upgrade procedure first thing in the morning. So after a very short night, John came back to the office, made himself a morning coffee, and started to deploy several fresh environments with the modified scripts to verify that they are working properly. After several tries, everything was working perfectly, and he started to upgrade the old infrastructure one by one. So he started to replace each instance one by one, and it went very smoothly. There was no downtime on the company application, as everything was load balanced using ELB and Marathon LB that handles the load balancing in DCOS. So to sum up, the upgrade procedure, at least for AWS, looks like that you have to destroy everything and start with new one. You can replace one by one each of the components. Overall, the process is very easy, but looking for changes in CloudFormation templates is very, very painful, as there is no changelog between versions, what has changed in configuration. So you have to find out yourself what has changed. And it so far worked every time. So it's not as hard as you might think. So let's move on to the present day. Is John happy with his choice? Is his boss happy with his choice? So after several months of running DCOS, company application has scaled much better than before. And implementing the big data analytics has increased the company revenue. So of course his boss is very happy also. And his choice of tools to do all the stuff that he had to do was very good. He's very happy of that. And for sure you can also think of that as a good example, which tools you could use in your infrastructure. So what are the key takeaways from these keynotes? First of all, DCOS is awesome. Most of you probably know that. If I didn't convince you, you can try out yourself. There's a Vagrant file provided by Mesosphere or Mini Mesos that you can use to find out what Mesos is, what DCOS is, play with it, and check if the DCOS fills all your needs. And the second one is that the infrastructure as a code is a way to go. So defining your infrastructure as a code, increase the visibility of the infrastructure definition. It's much better to read the code than looking at the several thousands of diagrams with complicated connections by the new people that come to the company. And Terraform is a great tool to help you with this approach. If you didn't have a chance to try it, for sure, at least check it out. It might change your life. And another thing that it's worth mentioning is that you should change your mindset from X should never die, no worries, to what if X will die? So what will be the consequences if this component will disappear? What will be the influence for the other components? So always think ahead, plan ahead, try to make everything highly available so there's no single point of failure, and try to provide as much high availability as you can. And the last thing, automation will simplify your life. So if the task is repeatable, for sure it can be automated. And if it can be automated, it can be codified. So thanks. And one last thing, some questions?
Question?
Yes, how did John solve the problem of load balancing between these two clusters, Mesos clusters?
There was one cluster.
Yeah, but during upgrade you had...
You perform the upgrade on the same cluster. So you have a working cluster, and for example, the upgrade procedure looks like if you destroy the one Mesos master, and the new one is launched, joins the cluster, and you replace another one. So you replace each of the instances one by one on the living cluster. So there's no new cluster that you migrate from.
Okay, and there was no compatibility problems between these two versions?
Fortunately, no. So.
Thanks.
So one question from me: how does John Scale. So I work for a, I guess, small company, but we already have a need for like 12 separate clusters. I'm talking about different environments: sandbox, staging, QA, performance, production. We have like 2 products plus 1 cluster for third-party applications. So I'm already like 12 or maybe 16 separate clusters. And if I will have to go your route, it doesn't scale. We have 6 people in operations, and we should manage that.
Why it doesn't scale? So you create a very generic Terraform modules that you just template, and you can create a new environment and like providing the variables file, and all the modules are the same. So you can create dev environment, staging environment, and it only differs in the variable definition. The the backends of the scripts, Terraform scripts, are the same for each of the environments.
I'm more talking about the overhead of actually doing the cluster upgrades. You said that you replace components one by one. I understand that this may be like auto-scaling room if you have a couple of them, but still it doesn't feel like it scales. Plus, you are always talking about the happy path. You said, fortunately, never broke, but I'm much more interested in the sad path when things actually break. I'm more interested in like having 2 production clusters, load balancing traffic between them, testing load, testing resource usage, having a quick rollback. Because you have tons of stuff to upgrade, from kernel to underlying system to Zookeeper that keeps the state, to Docker, maybe Docker storage engine. There are so many things that can go wrong with this simple DCOS upgrade that I'm not interested in the for the happy path.
So this is one of the approaches. So the other approach is to, as one of the colleagues mentioned, create a new cluster and migrate all the apps to the new cluster.
Yeah, but what happens with the stateful apps then?
Depends on the stateful storage that you have. If you have, for example, EBS that is pinned to the no, you don't have that. Local storage, SAF.
I mean, we do, but like it doesn't solve all the issues of, for example, having the 2. I mean, this depends, of course, on the thing you deploy, right?
That's true.
But still, having the ability to migrate state from one cluster to another, this is something I would like to see from DCOS.
Well, you cannot run another instance from the same EBS volume. So unless you have a shared storage behind it, like Ceph, you won't probably be able to run the same application with the same backend. Storage backend.
Are there any projects that try to do something like communication between 2 different clusters and migrating like applications one by one? You've mentioned that you have virtual IPs, there are some load balancing, you can service discovery. Do you have an ability to, for example, point that application number 1 or Elasticsearch number 1 is now handled by the separate cluster and route traffic there? Are there any developments in that area?
Not I'm aware of, but probably there's a way using what you use public cloud, private cloud.
We're in AWS.
So probably you could just use the ALB to the application load balancer to route the traffic to another one and drain the others.
Okay, thank you.
One more question?
Thank you for a great presentation. I have one question. Could you describe continuous deployment pipeline, if any, in John's company?
Okay, so as an example, they use Git as a source repository. They also have Jenkins. So the pipeline looks like that developers push the code to a separate branch. Tests are run. If tests are passing, the Jenkins deploys the version of this code to the development environment, which just talks with Marathon API, and the actual deployment looks like that you change the tag in the container image. So the Marathon just knows that he has to download the new version. And if everything passes, the application is promoted to the production environment.
So do you run you promote container or code? So In production environment, you use the container created in staging environment or create new container?
No, the environments are completely separate, so you're not able to migrate the container. Just use the code. If all tests have passed, so all the unit tests or the web tests have passed, the application is just released to the production environment.